Here in 3.2, we're going to continue talking about our theme of radians. And then we're going to actually start finding some measurements in reference to a circle. So the first equation we're going to talk about is something that was kind of a nice to know topic in geometry, not necessarily a need to know, so we're going to kind of revisit it. Not that it's super difficult, it's just another formula that you can learn, and you're basically going to plug in and make the computation. So the first one is, what if we wanted to compute the actual length of an arc in a circle? So the way that we can do that is by multiplying the radius times the angle. Okay, so the equation is here twice. The radius times the angle. The biggest thing I want to emphasize throughout this video is that now that we have shifted into how to find an angle in radians, how to convert from degree to radians, all of these angles that we're going to talk about today need to be in radians. So when we refer to theta, we have to have this in radians. If it's not in radians, then it's not going to actually calculate it properly, okay? Because it's all back in reference to the unit circle. So what this means, so let's draw ourselves a little picture here. Let's draw a little circle. Oh, that's not great. Let's move her down here. All right, so back in geometry, you learned about something. We did a whole unit on circles. Oh, wow, that's not good. Zoom in a little bit for ourselves. Okay, so let's say we had this angle that was right on the center of this circle. This is called a central angle because it's on the center of the circle. Okay, so we're going to call this theta. Let's say that's the angle that we know. Okay, hopefully we remember that our radius goes from the center of the circle out to the side, so this is our r. And then the arc length that we're trying to find is the arc length created by the central angle. Okay, so in geometry we talked about what would be the measurement of this arc, what the measurement of the arc is, but we didn't necessarily find the length of it. So this is your arc length. Okay, so we're basically figuring out how wide is this angle making an arc on the circle. Okay, so if we shift down here a little bit, we have two equations that we're going to talk about. So we're going to reiterate this equation here. Okay, remember the angle must be in radians, as always. Okay, so to put this in just terms that you can refer back to quickly and not remember what S is and whatever, your arc length is equal to your theta times your radius. Okay, radius now is always going to stand for r. Okay, and remember your angle is in radians. Okay, so your arc length is basically just almost this part of the circumference that the angle is creating. Okay, we have something else that is called the sector. Okay, the sector is this middle piece in here, basically the piece of the pie or the pizza, I always like to think about it, that this angle is actually creating. The area of this window that the angle is creating. So in order to create the area of the sector, we're going to think about this as 1/2 the radius squared times your angle. Okay, and as always, your angle must be in radians. So to kind of write this in better terms, so you have it. So your sector, I should put area, I guess, area of sector, is 1/2 times your radius squared times your angle. And of course, your angle is in radians. Okay, so if it's easier for you to write it that way instead of trying to remember what all the variables is, feel free to do that, okay? And then just a quick side note, if your angle is in degrees, you can always convert it to radians. Oh goodness, that's not good. See, feel free to convert that to radians. And then that way you can plug it into your equation. But if you don't convert it to radians, then it's not going to give you the correct answer. Okay, so this nice box down here gives it to you both ways. It's probably easier just to convert it to radians and plug it in. The pi over 180 here is just basically converting it to radians for you, but I would recommend converting it to radians and then plugging it into the equation. Okay, so let's do a couple examples. So what happens if we need to find our arc length? Okay, our arc length, if you remember, started with S, and it is our radius times our angle when our angle is in radians. We know that this angle is in radians because it contains pi. So what we're going to do, let me just start a new line. We're going to take our radius, which is 15, multiply by our angle, pi over 3. So 15 pi over 3. 15 over 3 would simplify to just 5. So our answer would be 5 pi. Okay. Same idea, different numbers. Still trying to find our arc length, but this time our angle is in degrees. I know that 1 because it has a degree symbol. Giveaway. 2, it doesn't contain pi. So if it doesn't contain pi or tell us that it's radians, then it's not going to be in radians. So let's first convert this to radians. So we're going to take our degree, multiply it by pi over 2. No, not pi over 2. Pi over 180, goodness. So we get 113 pi over 180, which doesn't really help us. We can't simplify that at all. So our arc length is our radius times our angle in radians. Okay, when we multiply across, 20 times 113 is 2,260 pi over 180. I want to leave pi in there for now and just try to simplify the numbers. So 2,260 over 180 actually simplifies to 113 pi over 9. Okay, and if it asked you to give it as a decimal, we could plug this into our calculator and it would give us about 39.44. Just be careful when you're going through your practice. Make sure, does it say in radians? Does it say to keep pi in your answer, or does it say to round? Just make sure you're entering that correctly because sometimes it changes on you. All right, and then our last problem is just going to be area of a sector. So our area of a sector equation is 1/2 the radius squared times our angle. And in both of these equations, we need our angle in radians. Again, we know this one is in degrees, one because it has a degree symbol and it doesn't contain pi. So just for fun, let's convert it. Not for fun, we really have to. So we're going to multiply it by pi over 180, which would give us 180 pi over 180, which is still just pi. If you knew that off the top of your head, feel free. You don't have to necessarily show the conversion. You can just put pi if you want to. All right, so now that we have pi, we're going to plug it into our equation. So 1/2, our radius is 30 squared, times our angle, which is pi. All right, so 30 squared would be 900. 900 times 1/2 would be 450. And then we have times our pi. Okay, if it had asked us to enter our answer in decimal form, this would estimate to about 1,413.72. Okay, So now that you have both equations, you can relate back and forth finding the area of the sector to the arc length, because you would have the same radius if you had to find both in a circle.